All right, let's get right into it. Today we are tackling one of the biggest, most important topics in AI right now, MLOps. We're going to break down exactly how you take a machine learning model from just an idea on a laptop and turn it into something real that people can actually use.
But first, let's start with a really important question. Why is it that so many amazing, brilliant machine learning models just die? They never see the light of day. We hear about all these incredible breakthroughs, but a shocking number of them get stuck in development. Some people call it pilot purgatory, and they never actually deliver any value. That is the exact problem we are here to solve today. And yeah, that problem has a pretty grim name: the model graveyard. It's this huge, dangerous gap that separates the clean, tidy world of building a model from the messy, unpredictable world of running it for real users. And this really shows you what I'm talking about. These are two totally different universes. Over on the left, you have development. Think of it like a perfect laboratory. Everything's controlled, the data is clean and predictable, and it's all running on one person's machine. It's where you prove a model can work in theory. But then there's production. That's the real world. It's chaotic. The data is a total mess, and it's always changing. And you're not on one machine anymore. You're on a massive, complex system, where if something breaks, it's a really big deal. That gap between them is enormous.
So, how in the world do you build a bridge across that chasm? Well, that's where MLOps comes in. MLOps is the hero of our story. It's the set of practices designed to do exactly that, to build a safe, reliable bridge from the lab to the real world. So what is it really? MLOps, which stands for Machine Learning Operations, is all about how we deploy and, just as importantly, maintain our models out in the wild. And here's the most crucial part. MLOps is not a single tool you can just go buy. It's a culture. It's a whole new way of thinking about how teams should work together.
And that new way of working is really built on these four big ideas. First, automation. You want to automate everything you possibly can, because manual steps are where mistakes happen. Second, reproducibility. You have to be able to perfectly recreate any model or result, period. Third, collaboration. Breaking down the walls between data scientists, developers, and the operations folks. And finally, monitoring. Because once a model is live, your job has really just begun. You have to watch it like a hawk.
Okay, so principles are great, but how do you actually do all this? Well, you need the right tools. The best way to think about it is that we're building a modern factory, an assembly line. But instead of building cars, we are building and shipping AI models over and over again. Here's a quick look at the starting lineup for our AI assembly line. We've got Docker to package things up, Kubernetes to run them at scale, MLflow to keep our science organized, Jenkins to automate the whole process, and Prometheus to keep an eye on everything. Don't worry, we're about to dive into each one. First up is Docker. And honestly, the best analogy for Docker is a shipping container, but for software. It is an absolutely fundamental piece of the puzzle. You know that classic, infuriating phrase in all of tech, but it works on my machine? Well, Docker is designed to kill that problem forever. It takes your model, all its code, and every single little library it depends on, and bundles them all up into a neat, tidy, standardized package called an image. This means it will run the exact same way everywhere, no exceptions. Okay, so you've got your perfect little container. That's great. But what happens when you need hundreds, maybe even thousands of them running at the same time to handle all your users? Well, that's where Kubernetes comes in. If Docker is the shipping container, Kubernetes is the entire port authority, managing all the ships. It's the orchestra conductor. Kubernetes basically takes over the job of managing all those Docker containers for you. If a ton of users show up, boom, it automatically scales up and adds more containers. If a container crashes for some reason, poof, Kubernetes just replaces it instantly, no one even notices. It's what's known as self-healing. It is, for all intents and purposes, the operating system for your modern cloud-based applications. All right, let's hit rewind for a second and go back to the lab, back to the experimentation phase. How do you keep track of all the different things you're trying? That is the job of MLflow. Think of it as the ultimate digital lab notebook for a data scientist. So every single time you train a model, you're tweaking things, right? You change a parameter here, use a different data set there. MLflow logs everything, all of it. The code, the data, the parameters, the results. This makes your work totally reproducible, which is absolutely essential for doing good science and for fixing things when they go wrong.
So we've got our containers, a way to manage them at scale, and a notebook to track our experiments. But how do we connect all these pieces so they work together seamlessly without anyone having to press a button? That's Jenkins. It's the automation engine that powers our assembly line. Jenkins is basically the glue. It's what creates something called a CI/CD pipeline. So imagine this. A data scientist pushes some new code. Jenkins sees that change and automatically kicks off a workflow. It tells Docker to build a new image, then it runs a bunch of automated tests on that image, and if and only if everything passes, it tells Kubernetes to deploy it to production. It's total automation.
And we're live. The model is out there serving users, so we're done, right? No way. Not even close. Now we have to watch it. We need to make sure it's healthy and behaving correctly. And that is the job of Prometheus, our system's health monitor. Prometheus is constantly collecting data, metrics from your live system. It's tracking everything: server load, response times, model accuracy, you name it. Its whole job is to answer that one critical question. Is our model still working correctly out in the real world? And if the answer is no, if it sees a spike in errors or something looks off, it immediately sends out an alert so the team can jump on it.
Now, these 5 tools we've just covered, they are the absolute giants. They're the foundation of MLOps. But this field is moving so fast, and there's now a whole ecosystem of other, more specialized tools popping up.
And this just gives you a little taste of that. You've got specialized tools for versioning your data, just like you version your code. You have things called feature stores that are just for managing the inputs to your model. You even have incredible tools that help explain why your model made the decision it did. The big takeaway here is that the MLOps space is just constantly innovating and growing. Okay, so we've looked at the problem, we've talked about the philosophy, and we've met the core tools. Now let's put it all together. Let's watch our AI assembly line in action from start to finish. And here it is. This is the entire flow. It starts with a data scientist doing their work, tracking everything with MLflow. When they're ready, they commit their code. That's the starting pistol. Jenkins sees the change and tells Docker to package it all up. That new package gets automatically put through a battery of tests. If it passes everything, Jenkins gives the green light, and Kubernetes deploys the new model to real users. And the whole time, from beginning to end, Prometheus is watching over everything, making sure it's all running perfectly. That is MLOps. It's a smooth, repeatable, reliable process.
So, by adopting this way of thinking and using these tools, you have officially crossed the chasm. You've left the model graveyard behind, you've built yourself a powerful, efficient assembly line for innovation. So now the only question left to ask is, what are you going to build with it?